Hey, algebra students, last class we talked about solving equations, learned the basics of that. Now we're going to up our game and look at solving two-step equations, and it is going to relate to something we learned back in the basics. Let's take a look. So first of all, I'd just like you to remember what it means to solve. When we are solving, we are finding a value of the variable. What am I saying? Find a value of the variable. Guys, I just mean like what number is the letter equal to? So find a value of the variable that makes the equation true. I could say statement true because equations aren't the only time we solve, but they're the only one we know about so far. Now, how do we do that? That's a great question. So it's one thing to know what it is to solve, but how do you solve? Well, if we want to know what is the value of the variable, let's say like the variable is x, then we want to know what x is equal to. And we want x to be equal to a number. That means to solve, we are going to do what's known as isolate the variable. We're going to get the letter alone on its side of the equal sign. Once it's alone, then we'll know what it's equal to. Pretty simple. How are we going to do that? We're going to do that using inverse operations, opposites. One other thing that I will remind you of that we really stressed last class is that we can solve equations. So like, here's a great example. One of these can be solved and the other one cannot. The first thing, x plus 3, is simply an expression. There is no information about x plus 3. I don't have any hints about x plus 3. There's no way to figure out what x is. But in the second line there, this is an equation. X plus 3 is 7. Now I have a clue that tells me something about x plus 3, and I could use what I know about x plus 3 to try to figure out what x itself is equal to. Like I said, equations aren't the only thing that we can solve, but the main thing we need to realize is that we can't solve expressions. So let's go ahead and now let's compare this though, because solving is a new concept to us. For a long time in math, we actually have not been solving. We've been doing what we call simplifying. And we talked about that in the Crucial Basics unit. But if you never went over that with us, it would be important for you to understand what I mean by simplify. When I say that I want you to simplify, I'm not talking about finding a value of a variable. This is not finding out what the letters equal to. When I ask you to simplify, I'm literally just having you obey the indicated operations. So for example, if I gave you an expression like 6 plus 3, simplifying this would be to do the operation you see. What operation do you see? You see addition. So if you do the addition, you have simplified it. You say 6 plus 3 is 9. That is not solving. Feels like solving, but that is simplifying, as we say. So you might say, well, why do I care, Kate? Why do I even need to know this? And it turns out it's really, really important to understand the difference between simplifying and solving. Because I said when I'm simplifying, I obey the indicated operations. But when I was solving, I used inverse operations, right? I did opposites. When it said add, I subtracted. When it said multiplied, I divided. I was getting rid of math. In fact, let's put that down. If this is obeying the indicated operations, it's doing the math you were told. Solving is doing the opposite of what you were told. It's getting rid of math. And that's not the only way simplifying and solving differ. When I simplified, you just simplify one expression. For example, like I said, if we have the expression 6 plus 3, we just do one thing there. 6 plus 3 is 9. But remember when we were solving, like if we had something that said x plus 3 is equal to 6, we wanted to get x alone, so we'd do the opposite, like we said, subtracting 3, but we didn't just do it once, right? We said it was so important to keep our balance. And so this thing ended up being two-sided. I ended up doing that same thing, subtract 3, to both sides of an equation, both expressions. So when you're solving, you have two expressions. And so you do the operation twice. So a lot of differences here, right? So simplifying is when we obey. Solving is when we disobey. We do the opposite of what we've been told. Simplifying is one-sided. Solving is two-sided. We simplify expressions. We solve equations. A lot of differences here. And now I want to get to a super duper important difference you need to understand now that we're looking at two steps. And that is with the order of operations. Anytime you have to do more than one thing, you should be asking yourself, what should I do first? And we learned the order of operations when we talked about the crucial GED math basics. And we said that the order of operations was first our groupings. And remember, yes, groupings can be indicated by parentheses, but that's certainly not the only way. Groupings can also be inside of brackets. They can be inside of square root symbols. Shoot, groupings can be inside of fractions. You can have a group on the top and a group on the bottom of a fraction. So the main thing about groupings is not what grouping symbol we use. The main thing about groupings is that they're inside. We work inside to outside. And then we said after we had done any groupings, we would take care of exponents. That's our next priority. Now, do remember that exponents are the little floating numbers and their inverses, the radicals. And if you're mad at me because I have that square root symbol over both the G and the E, remember that the grouping is the inside. So I'm saying I would work inside first, and then I would do the exponent next. So that's this difference there. After we were done with any exponents, then we said we would do multiplication and its inverse, division, part of the same step. And then finally, last step to that order of operations was addition and its inverse, subtraction. And we talked a lot about this. This is the order that we're going to do it when we're simplifying, when we're obeying the operations. So for example, you can see that I have two operations in this expression. This is an expression. There's no equal sign. There's no other side. So all I can do is simplify, obey the symbols. This says 2 plus 5 times 7. Well, I've got addition and I've got multiplication. According to the order of operations, I would have to do the multiplication first. 5 times 7 is 35. And drop the thing I haven't used. And then that would simplify to 37. Now, how, though, is that going to be different than solving equations? Let's look at a similar equation. So how about we do 2 plus 5p equals 7. Now, this is an equation, right? We have two sides. We have something equal to something. Now I have the power to solve, to work to get that letter alone. And you can see that P is not alone. There's two numbers hanging out on the same side of the equal sign with P, 2 and 5. And so the question remains, if I have two things to get rid of, in what order do I go? And you might say, Kate, I have the order of operations memorized. I'll just get rid of whatever's multiplying, dividing before I handle whatever's adding, subtracting. And I would say you're wrong. And it's not because the order of operations is suddenly wrong. It's because you're not thinking about what you're doing right now. Remember that solving is undoing math. Solving is doing the opposite of what you've been told. And guess what? If you want to undo it, you want to do the opposite, work the order of operations backwards too. We are going to work the order of operations backwards when we're solving. We're going to get rid of any numbers that are adding or subtracting first. Then we'll take multiplying and dividing away. Then we'll move away the exponents on the variable. And finally, we'll save our grouping for last. All right, that's it. That's all we need to know. Let's look at some examples. Is for a solution to the equation 20 equals 3j plus 14. I don't even have to solve this. Somebody else tried it for me. What I'm doing here is checking their work. Remember what a solution does. A solution is a value for the variable. So it's what j would have to be in order to make the statement true. J is what you'd have to multiply by 3 and add 14 to in order to get 20. So if somebody already has a guess, let's just give it a try and see. If I multiply that with 3, add it with 14, will I get 20? 3 times, we're guessing 4 plus 14. What does that give me? Does it give me 20? No, it gives me 26. So is 4 a solution? No, it's not. Now, that being said, let's just go ahead and solve this sucker. If they didn't have me guess a solution, they just said solve. Now's when I would start working backwards. My goal, get the letter alone, but I've got 2 numbers hanging out, 3 and 14. We said when we are moving across the equal sign, we're solving, we're going to work that order of operations backwards as well. So let's move anything adding or subtracting first. So I'll move 14. Now, how? By doing the opposite. 14 is currently adding. What's the opposite of adding? It's subtracting. And I can do whatever I want as long as I do it to both sides. Keep your balance. Adding 14 and subtracting 14, zero out. I just have 3J. And be sure you keep your equal sign. A lot of beginning level students lose equal signs. And 20 minus 14 is, of course, 6. And now, unlike with the problems we were doing before, we're not done yet. Why? J's not alone. There's still a number with J, right? 3 is over here. So I've got to get rid of 3. But using what operation? Well, I got to do opposites. And what's 3 doing with J right now? Well, they're shoved together. They're multiplying. So I need to divide. And I can do whatever I want as long as I do the same operation with the same number to both sides so that I keep the left and the right-hand side equivalent. 6 divided by 3 on the left is 2. And of course, multiplying and dividing by 3 are opposites. They cancel. I just have one single solitary J. So what would J have to be in order to really make this right-hand side equal to this left-hand side? It'd have to be 2. And take a look. 3 times 2 plus 14, that does give me 20. Okay, no solutions to test this time. I'm on my own. I just have to solve. So I'm going to put that nice line through my equal sign so I can see what I have to get rid of. I have a 9 here, multiplying with M because it's shoved up against it, and a 7 here, subtracting with M. And so I'm going to work that order of operations backwards. I'm going to move anything adding or subtracting first. I'll take subtract 7 away by adding 7. And again, when I do opposites, that's two-sided. I have to do it to both sides. I can only be disobedient if I keep the left-hand side equivalent to the right-hand side. So subtracting 7 and adding 7 are opposites. They cancel. I'm left with 9M on the left-hand side. Keep your equal sign. And on the right-hand side, 29 plus 7. You guys, I know what 29 plus 7 is, and I know you guys do too, but man, when you get nervous on test taking day, y'all can do all kinds of silly things. I recommend you just do it in your calculator. Now, I'm not done. M is not alone. I have this 9 to get rid of. Don't just write them there without saying what operation you're doing. 9 and M are shoved together. They're multiplying. I'll do the opposite. I'll divide. I get rid of math by using inverses, opposites. I can do whatever I want as long as I do the same operation with the same number to the other expression. Multiplying by 9 and dividing by 9 are opposites. They cancel. M's alone like I wanted. And 36 divided by 9 is 4. And now, am I done? Yeah, I am. M's alone. M would have to be 4. Because if M is 4 and I do 9 times 4 minus 7, I will get 29. Next example, I am trying to freak you out with fractions. Do not get freaked out. So let's read this in order to help us to understand. Yes, one way to read this is P over 6, but remember, I can also say P divided by 6 plus 15. Reason why I chose to say it that way is I want to emphasize what that 6 is doing with P. So I can see, yeah, there's 2 numbers to get rid of, a 6 and a 15. And the 6 is dividing, the 15 is adding. And we said that if there's no groupings, because I save groups for last, I'm going to move anything adding or subtracting first. And so I'm going to move that 15 first by doing the opposite, by subtracting. Can I do that? I sure can, as long as I do it to both sides. And let's see what our new equivalent equation will be. Well, adding 15 and subtracting 15 are opposites, so they will zero out. They'll cancel. and I'll just have P over 6. And that's going to be equivalent to whatever I get on the other side. And of course, 19 minus 15 is just 4. Now, almost done, but P is not alone. I got to get rid of that over 6, but over doesn't tell us an operation. So better to think of it as P divided by 6. The opposite of divide is multiply. Bring that up nice and high, guys. Make the 6 line up with the P, or else you're going to be one of those confused students who says, isn't 6 times 6 36? I'm not doing 6 times 6. I'm doing 6 times P, and P is also dividing by 6. So multiplying P by 6 and dividing P by 6 are opposites, so they cancel. Now, can I do that? Yeah, as long as you do it to both sides. So if I multiply the left-hand side by 6, I'm also going to multiply the right-hand side by 6. And let's see what our new equivalent equation will be. Well, the only thing left on the left-hand side, yay, is P. And then on the right-hand side, there's the work to do. And 4 times 6 is 24. This is my last beginner example, and a lot of beginners will get traumatized and freak out at this, but look at me, look at what I'm saying to you. You are no longer scared of fractions. The day you got the equation, you got the power to get rid of fractions, and that's in fact the thing that we're going to do first here. Take a look at this. K is not alone. There's a couple of things going on with K. K is subtracting with 3, but take a look at the fraction bar this time. This time the fraction bar stretches nice and long over K minus 3. So that entire group of K minus 3 is dividing by 5. Now, remember what we said. When we're working that order of operations, groups come last. So the common student error that students will make is they'll try to move that subtraction, that minus 3 first by adding 3, but you can't, because right now that K minus 3 is a group. You've got to save the group for last. So let's start with anything that's outside of the group. So examine the group. What's outside of that? That's the 5. So that's what we're going to move first. And again, you can move it using opposites. So that 5 is dividing the group. So you will multiply the whole darn thing by 5. And again, I want to see it nice and high lined up with that grouping. And now you can do whatever you want as long as you do it to both sides. So I'll enclose the entire left-hand side in parentheses, multiply that by 5 as well. 5 times 8 is 40, and that's going to be equivalent to, and then don't panic about how ugly this is, you guys. Dividing by 5 and multiplying by 5 are opposites. It cancels, and all I'm left with is K minus 3. And now that it's been released from that grouping, now I can do the opposite of minus 3 and get rid of it by adding 3 on both sides. Subtracting 3 and adding 3 are opposites. K is alone, just like I wanted, and 40 plus 3 is 43. Right on, beginners. Look at us. We're not scared of fractions. Let's look at some experience level practice. So first one, solve 64 is equal to 39 minus n. Now you might be thinking, hey, Kate, this doesn't seem so experienced to me. In fact, it seems easier than the other ones. Isn't this a one step? There's only one number to get rid of. Well, it's actually a two-step in disguise. Let me show you what I mean. 64 is equal to 39 minus n. I've only got one number to get rid of, right? The 39. Problem is, most students pick the wrong operation. They say, well, look, there's this subtraction sign between 39 and n. I'm going to do the opposite. I'm going to add. And let's just go along with it. Let's say you did add. What would happen if you took 39 and added 39? First of all, it just looks weird that you put the plus sign over there, okay? But what is 39 plus 39? Let's just consider. Well, 9 plus 9 is 8, and then I'd get 78. And of course, I would need to add 39 over here as well. And what would I get? 103. And then I'd have the minus n that I didn't use. Now, is this true? Yes, this is technically an equivalent equation. I can add 39 to the right-hand side as long as I add 39 to the left-hand side. However, I did not make my life any easier. Why? Because 39 did not cancel. 39 plus 39 is not 0. And so even though it was illegal, it wasn't wise. It didn't achieve my goal. Let's think about this another way. I have 39. And yes, 39 is separated from n with a minus sign. So therefore, 39 is a term, right? Numbers adding and subtracting are terms. So it does need to move through addition or subtraction. But your goal is to get that 39 to go away, to get it to zero out. Well, I'm going to need to subtract 39 since that's a positive 39. Go up 39, go down 39, that'll zero out. I can do whatever I want as long as I do it to both sides. And now look at what happens to my equation. Adding 39 and subtracting 39, that is 0. So it's like I have nothing, take away n. Well, think about what happens when you have nothing, 0 minus something. If I have nothing and I spend $5, I'm going to be in debt $5. It's like the 0 just went away. If I have nothing and I spend $17, I'm going to be in debt $17. It's like the 0 just went away. So same thing with n. If I have nothing, I got that 39 to go away, and I subtract n from that, I'm going to have negative n. And so what I'm going to see is the 39 cancels with the negative 39, but that minus is still there. It just now we read it as a negative n. And then on the left-hand side, I'm going to do this in my calculator because I've made dumb errors on videos too many times. 64 minus 39 is 25. Now, again, this is where inexperienced student might stop. But you guys, my experienced students, I'm expecting you to realize that n is not alone right here. We don't know what n is equal to. We know what negative n is equal to. Now, if that's really confusing you, let's remember that the invisible coefficient when you can't see a number is 1. So negative n means the same as negative 1n. Looking at it that way, it's easy to think, oh, okay, so I could just divide away the negative 1. And of course, whatever I do on one side, I do on the other. And then I'll see that multiplying and dividing by negative 1s are opposites. They'll cancel. N is alone. And of course, when I take 25 and divide by negative 1, I can do it in my calculator if I need to. But, you know, the number 1 doesn't really change anything. So all that's going to happen is he's going to get his sign changed. Positive 25 is going to turn into negative 25. Now, this is my answer. I'm done. N's alone. So n's not equal to 25. N's equal to negative 25. Now I have to warn you, your college teachers are going to skip all this in blue. Your college teachers are just going to say, hey, if 25 is equal to negative n, then n must be equal to negative 25. And sometimes students get confused. They're like, how come the negative jumped over the equal sign? Not what happened. They said, if I change the sign on the right-hand side, I negate it as another way to say that, then I'm going to change the sign on the left-hand side. I'm going to negate it. So it's just a little shortcut because they know what happens when you multiply or divide by negative 1. All right, nice. Let's look at another tricky example. Now, this one I picked for all the negatives because it gets just really tricky to keep track of which one's a negative, which one's a minus. So I think the best thing to do on an example like this, which will be fun when you're testing because you might have to do it under your breath, but is to read it out loud. Oh, by the way, if you're testing online, you can't even read it out loud. They're afraid you're talking to somebody in the room. I'm sorry. You have to like not move your lips, but imagine saying it in your head or even write it down. Negative 3p minus 41 is equal to negative 27. Now, why did I read this one as a negative and this one as a minus when they look identical? Good question. Well, when it's in front, it has nothing to subtract from. So we just read it as negative 3p. But when it's in the middle, we don't read that as negative 41 because it has something to subtract from. It's subtracting from that first term. And so I read that as minus when it's in the middle. So negative 3p minus 41 is equal to negative 27. Now that'll help us to see what these two numbers are doing. Negative 3 is shoved up against p, it's multiplying, but 41 is separated from p by that minus sign, it's subtracting. So if I am, like I said, working that order of operations backwards, there's no grouping here, so I'll just move anything adding or subtracting first. So I'm going to get rid of that 41 by doing the opposite, by adding it. Of course, I can do whatever I want as long as I do it to both sides. Subtracting 41 and adding 41 are opposites. They will cancel, and I'll be left with negative 3p. And that's going to be equivalent to whatever I get on the other side. So negative 27, use your calculator, use your calculator. The most common error students make while testing is with negative signs. So negative 27 plus 41 is 14. Now P is not alone. Now really, really common error. A lot of students do this and they're wrong. Why are they wrong? It's not because negative 3's opposite is not positive 3. That's not why. It's because that's not what P and 3 are doing. We are trying to break the bond between negative 3 and P. We can only break the bond between them if we look at what they're doing with each other. Negative 3 and P are shoved together. So if I want to break the bond between them, I must do the opposite of that. That's multiplication. I divide. I'm going to divide away the number I want to get rid of, the negative 3. Keep that sign. Another common error is to jump across the equal sign and just put 3. But if I divided by negative 3 on the left-hand side, I better divide by negative 3 on the right-hand side as well. I want the two sides to remain equivalent, equal. So I must do the same thing. Now let's see what happens. Multiplying by negative 3 and dividing by negative 3 are opposites. They're going to cancel. I'm just going to have one single solitary P. Now, 14 divided by negative 3. You type it like this, you're going to see this nasty answer. As a general rule, we don't like rounded decimals in pure math. We use them in applied math, like if I was geometry or something and I wanted a side length, I'm more likely to use them. But when it's just pure algebra like this, I usually like fractions better. So I'm just going to hit the quick convert button, turn that into a fraction. So that's the same as negative 14 over 3. What does a mathematician do when they're too lazy to divide? They use a fraction. That's why fractions exist, so I don't have to do ugly decimal division. You're welcome. All right, that's the final answer. It's done. I know your third grade math teachers like scarred you half to death about fractions like this when the top is bigger than the bottom, improper fractions, and they like made you freak out. You think this is not a good answer and you have to convert it. You don't. It's fine. It's a fine answer. We use them all the time in algebra. Another common GED trick, they love it, is to mix up fractions and decimals. And the nice thing is with our algebra skills and our calculator, we don't have to worry about that at all. So let's look at this example. 1.7 is equal to negative 4/3 x. Now, how come I didn't read this one as divide this time? Because x is not inside that fraction. So I can think of this as one just big ugly number shoved up against x. So negative 4/3 x plus 1/2. So looking at it that way, I have two numbers to get rid of. I have this negative 4/3, which we said was shoved up against x, so it's multiplying. And I have this 1/2, which is separated by x from this plus sign. It's a term. It is adding with x. Again, if I'm working that order of operations backwards and I have no groupings to consider, I'll just move anything adding or subtracting first. So I will take that 1/2, I will subtract it away. Can I do that? I can do whatever I want, as long as I do it to both sides. Make sure you get all the way across that equal sign. Let's see what happens on the right-hand side. Adding 1/2 and subtracting 1/2 are opposites. They cancel. I'm left with negative 4/3 x. And on the left-hand side might look ugly, but your calculator can handle 1.7 minus fraction bar 1/2, and I get 1.2. Now, I want to get rid of this negative 4/3, which is multiplying with x. You go on to college, you'll learn a nice little trick about multiplying with the reciprocal. You can just let this wash over you. If you already know that trick, go ahead, do it. You'll get the same answer. But I like to stick to one rule at a time, especially when we're first learning. So I'm going to say to myself, what is this negative 4/3 doing with x? It's multiplying. So I can for sure get rid of it by doing the opposite, dividing. So I'm going to divide away the negative 4/3. You say, can I do that? You absolutely can, as long as you do it to both sides. Now, don't let yourself panic because this looks so ugly, because between your knowledge of algebra and the calculator, it's not going to be ugly at all. Look at the right-hand side. We know that no matter how ugly the number is, if you multiply and divide by the same number, it cancels. So x is alone. And the left-hand side, yeah, that'd be kind of gross if I had to do it by hand, but I don't. I can do 1.2. Now, here's one time when I do want you to use the divide by symbol, when there's two fractions going on, or else you guys get too confused about which one's the main fraction and which. Anyway, I'm just going to say divided by, and then negative fraction bar 4/3. Enter, and I get negative 0.9. Now, this answer is absolutely true, right, good, and correct. but it is a decimal, which means there's another way to express this answer. There is a possibility that on the GED, you could get a decimal answer out of your calculator and they could have fractions in the multiple choice. So you would need to know, oh, hey, this isn't the form my answers are in. Which one of their answers is equivalent, is equal to my answer? So let's hit the quick convert button. Another perfectly true, perfectly legit, perfectly correct answer is -9/10. All right, don't get intimidated by example 8. This is one of those cases where something we usually find challenging, word problems, is actually going to be made easier by algebra. So the equation 96 is equal to 12h plus 2 times 6 can be used to find the height in inches of a triangular prism with a surface area of 96 inches squared, whose base has an area of 6 inches squared, or square inches, and a perimeter of 12 inches. What is the height of the prism? Now, if I didn't give you the equation and I just told you to find the height of this prism with the information, now that would be a little trickier. But I gave you the equation. Look, I gave you this relationship with a left-hand side and a right-hand side where the only letter is H, and they tell us H stands for height. So I gave you the equation that you can use to solve for or find height. So I'm just going to copy that equation down. A lot of times just taking it out of the word problem and looking at it by itself is all you guys need to have your algebra skills kick in. And there's another really nice thing about this particular equation. It might look complex to you, like there's 3 numbers to get rid of, but I can make this equation simpler. Before I start solving, moving back and forth across the equal sign, this little bit, I could actually do forwards. I can simplify. I know what 2 times 6 is. 2 times 6 is 12. Now, careful. When you simplify, when you obey the symbols, that's just one-sided. You're just making your equation a little simpler. You didn't really make a change to the right-hand side. That's what it already was, 2 times 6. It was 12. And so you only do it to one side. But now there's no more simplifying I can do. I can't do this addition. I can't do this multiplication. Now it's time to start solving, moving back and forth across that equal sign. So now I'm going to make sure I work backwards, moving anything adding or subtracting first. So let's subtract away that 12. Since it's adding. So adding 12 and subtracting 12 are opposites, they cancel. I'm left with 12h, and that's going to be equivalent to whatever I get over there. So 96 minus 12 is 84. Not done yet, right? H is not alone. There's that 12 shoved up, so it's multiplying. I'll do the opposite. I'll divide. Jump across the equal sign, do the exact same thing, so my sides stay equivalent. Multiplying by 12 and dividing by 12 are opposite. They will cancel. I'll just have one single solitary h, and that will be equal to whatever I get on that side. 84 divided by 12 is 7. So what's the height? The height is 7. Or forwards, 7 is the height. Same difference. All right. Nice job, experienced students. All right, advanced students, are you ready? First one I want to do with you, it's advanced mostly because you guys don't get so intimidated anymore, but this is a really common GED math test style. They like this example, and it's actually simpler than it looks. So I like it too, but it's really intimidating to students who are still scared of fractions. So roll with me and see how we're only 2 lessons into algebra, and we can already solve this example with just those 2 skills. Let me show you what I mean. Look at when we read this. Do you see how -5/2 is shoved up against this parentheses? It's shoved up against a grouping, meaning that -5/2 is multiplying by the whole group. So I think I'll say times the quantity of, to make that clear to myself when I read it aloud. So -5/2 times the quantity of 9r minus 7 is equal to -50. Now this time a little tricky because I do have 3 numbers to get rid of. This -5/2, this 9, and this 7. But same thing, I could just get rid of them one by one by following the opposite order of operations. Now there is another way to do this, kind of like the last example that we did in experienced, where you can do some simplifying first If you're a student who knows how to do that, great. Try it that way and see how we'll get to the same answer. But that being said, I'm going to just follow the principles I've been following today, which is to work opposite operations in the opposite order. Backwards. That means that in theory, I'm moving anything, adding and subtracting first. But remember, I can't add 7 here. Why? Because 7 right now is inside of a grouping. Okay, so let's move anything outside of the grouping first. I'm going to move the -5/2. Now, careful, because right now that looks like -5/2. What is that -5/2 doing with that grouping? It's multiplying. So if I want to move it, I have to do the opposite. I have to divide, stretch that fraction bar nice and long across the left-hand side. And I can do whatever I want as long as I do it to both sides. I will divide this side by -5/2 as well. Now, don't get intimidated by how ugly this looks, because our algebra skills and our calculator will handle it. Multiplying by -5/2 and dividing by -5/2 are opposite. They're going to cancel. All I'm left with is that 9r minus 7. And I don't even need the parentheses anymore because it's freed from the grouping. I did everything. I dealt with everything outside of it. And now this math, yeah, it looks gross, but again, I can put it in my calculator. -50. And again, when I have fractions, I'm going to hit divided by just so I don't get confused. So divided by negative fraction bar 5/2. Enter, and I get 20. And my troubling little fraction is done. My grouping is free now. There's no more groups to wait until last to deal with. I'm going to go ahead and get rid of that subtraction using the opposite addition. New equation will be 9r is equal to 27. Not alone yet. Got to move that multiplying r by dividing. Multiplying and dividing cancel, leaving me with r. And 27 divided by 9 is 3. And I am done because the letter is alone. Nice. All right, I got a nifty little trick for this one. So first of all, let's read it. It says 14.7 is equal to negative. Now, do you see how that negative is outside of the fraction? What I'm saying is that this entire thing is negative, not just the 1.8. That entire fraction is being negated. So negative, and then the quantity of 1.8 minus y over 3 or divided by 3. This guy's a little complex. So there's two things bugging me right now. There's two things outside of the grouping, right? Here's a group. I have this divide by 3. The whole group is being divided by 3. And I have this negative. The whole group is being negated. And so I'm going to get rid of both of those things at the same time. Here's how. The opposite of dividing by 3 is multiplying by 3. I'm going to multiply by 3. But I also want to get rid of the negative. And I know that a negative times a negative is a positive. Since that whole group is negative, if I multiply it by -3, it'll go away. Nice trick. So this negative and this negative will make it positive, and multiplying by 3 and dividing by 3 cancel. And so what am I left with on the right-hand side? 1.8 minus y. Now, could you have done that in 2 steps? You sure could have, but why when we don't have to? Oh, I tried to screw something up though, you guys. What'd I screw up? This is exactly why I tell you to do your change on both sides before you do anything else. That is, I made a change on one side. I broke the cardinal rule of solving. Bad girl. Whatever I do on the right-hand side, I must do on the left-hand side as well. So I must take the entire left-hand side and multiply that by -3. Ooh, Kate, you're getting tired. This is like my 837th take on this video, so y'all got to give me a break. So 14.7 times -3 gives me -44.1. Awesome. Now this one kind of looks like the first one I did with the experienced. I've got that 1.8 to get rid of, but the 1.8, it seems to be subtracting with y, but I need it to zero out. So don't be the foolish student who adds 1.8. 1.8 plus 1.8 does not make 0. If I have a positive 1.8, I need to subtract away the 1.8. -44.1 minus 1.8, I get -45.1. 45.9. And that's going to be equivalent to, well, 1.8 minus 1.8 zeroed out, but I have nothing minus y. So remember that negative belongs to the y. It's still there. But now I am going to be a lazy mathematician, you guys. I know that if I change the sign on the right-hand side, I will change the sign on the left-hand side as well. If negative y is equal to negative 45.9, then positive y is equal to positive 45.9. Woo. Okay, here's another example that looks harder than it is. It's actually fairly simple. So we see 64w cubed plus 3 is equal to 30. So we got a few things to get rid of in order to get w alone. We have this 64, which is shoved up against w, so it's multiplying. We have this floating 3, which is actually an operation, not really a number, but nonetheless, we still need to get rid of it so w can be alone. And then we have to get rid of this 3 here that's adding with w. And again, just following that order of operations backwards while we get rid of this math using opposite operations, we'll just send it all packing here. Let's move anything adding or subtracting first. So I'll take away the 3 using the opposite of addition, subtraction. New equivalent equation. Well, adding 3 and subtracting 3 are opposites. They cancel, leaving me with 64w cubed. And that's going to be equal to 30 minus 3 is 27. Now, I still have a couple of operations here. I have a multiplier and I have an exponent. I'm working backwards, so I'm going to move anything multiplying next. Let's take away that multiplier by dividing. We can do whatever we want as long as we do it to both sides. Multiplying and dividing by 64 cancel, leaving me with just w cubed. And that's going to be equivalent to, you're going to see in a hurry if you try to do 27 divided by 64, it's ugly. Could I write this down? You could, but my guess is you probably have your answer as a fraction. So I would look at my multiple choice answers at this point and be like, oh, are they fractions or decimals, to help me know which to stick to. But likelihood is it's probably going to be a fraction. So I hit quick convert and I can see that that's just 27 over 64. And there's a real reason that I like to do fractions, because the next step is actually easier with fractions than it is with decimals. And the reason why I wanted to do this. So w is not alone right now. W is being cubed. In order to get rid of a cube, I have to do the opposite of cube. The opposite of cube is cube root. So get that in your notes if you didn't know that. Just like the opposite of square is square root, the opposite of cube is cube root. Looks like a square root symbol, but with a 3 in the check mark. You say, can I do that? You can do whatever you want as long as you do it to both sides. Make sure you keep that little 3 though, or else you're taking the cube root of one side and the square root of the other. That would not be doing the same thing to both sides. So I'm going to take the cube root of 27 over 64. Different ways you can do this, and you can actually do this one by hand. It's not as hard as it looks, but I'm going to do it in my calculator. In order to do cube root, you're going to start with the number 3, the number you want inside the check mark. It's called the index. Got that 3? And then I need the xth root, not the square root. Okay, the xth root, which is right above that. So it's in green, so I'll hit second, and then I'm going to hit that caret button and see how that 3 went up in the sky. And I'm going to put the fraction inside, 27 on the top, 64 on the bottom, and I get a very nice fractional answer. So cube root of 27 over 64 is 3/4. And on this side, cube and cube root cancel, leaving me with just w. And now w is alone. 3/4 is the correct answer. A trapezoid has an area of 136 centimeters and a height of 8 centimeters. If the length of the first base is 15 centimeters, the formula 136 is equal to 1/2 of 8 times the quantity of 15 plus b can be used to find the length of the second base in centimeters. What is the length of the second base? Now, once again, like before, if I didn't have this equation here, I'd have to know a lot more than I do. But they told me that this equation can be used to find the length of the second base, and they want me to find the length of the second base. So they're basically just telling me to solve this equation. Let's just start by copying it down. And earlier today, I made the common student error of just copying an equation down wrong. So check yourself. And now it's time to solve. And once again, like we did back on the experience level, I have some straightforward math that I know how to simplify. Even though I might not be able to deal with that grouping with B in it yet, I know how to multiply together 1/2 and 8. And since all three of these things are just shoved together, 1/2, 8, and that whole group of 15 plus B are all just shoved together, they're all multiplying. And I can multiply in any order I want. So I can just do this piece of the multiplication to make my equation simpler. I can do 1/2 of 8 is 4. And even if you forgot that multiplication is an act of scaling, you can do 1/2 of or times 8 and see that it's 4 in your calculator. But be careful. I'm simplifying. I'm obeying the operation, which is just one-sided. So it just replaced that piece, but nothing else is going to change in my equation on either side. Now, there's actually two ways to go right here. But what we see is that we have this group that B's inside of. So I'm going to hold that group nice and steady. And I have a number that's outside of the group, the 4. It is time to deal with that 4. And like I said, there's a couple ways to deal with it. But we're just going to keep going the way we've been going. Since that 4 is multiplying the whole group, I'll get rid of it by dividing it away. I can do whatever I want as long as I do it to both sides. Left-hand side, that is 34. And that's going to be equivalent to, well, multiplying and dividing by 4 cancels. So I just have that 15 plus B. B is not alone yet. Let's subtract away the 15. 34 minus 15 is 19. And that's going to be equal to, well, 15 minus 15 is 0. So I have 0 or nothing plus B. Nothing plus B is, of course, just B. And so the length of the second base here is 19 centimeters. Nice. Are you ready? This is a skill most commonly used in science, chemistry, physics. We're going to use this skill. So you could see this particular style of problem on the GED Math or the GED Science tests. The equation E equals 1/2 mv squared is used in physics to find the kinetic energy of an object given its mass and velocity. Solve the equation for V. So that's nice. They told us to solve the equation, and here we have our equation. E equals 1/2 mv squared. And they told us what to solve for. They told us to solve for V. So I'm trying to figure out what V is equal to. However, they didn't give us the information that we usually like to have. If we were solving for V, we would usually want to know what the other numbers are. What's E? What's M? And this time we don't know it. And they do that all the time in science. They'll solve an equation before they plug in the numbers. They'll solve it when it's still just letters. And that freaks students out. Like, how do I move around variables? But I would remind you that a variable, a letter, it's standing in for a number. So it is a number. It's a number in disguise, but it's a number. So it's going to move the same way that numbers move. So here's what we're going to do. I'm just going to have you take whatever thing we're solving for, in this case of V, and put it a different color, because I need you to have some way to distinguish what's staying still and what's moving. So that V, that blue thing, that's the thing that's going to stay nice and solid, and we need to strip everything else away from him. Now, there is a trick that will be helpful for you right now, which I haven't been doing the rest of the time here, but I want to move this 1/2 multiplier. And I'm not going to move it by dividing this time, not because I can't. Like, it's true that I could divide E by 1/2 on both sides. It's just because this is not calculator work, right? Because of the variable. And most students don't know how to simplify E divided by 1/2. So I'm going to do it another way. I am going to get rid of a fraction multiplier by multiplying by what we call the reciprocal. The reciprocal of a fraction is its flip. So whatever is on the bottom of a fraction is going to come up to the top. And whatever was on the top of the fraction is going to come down to the bottom. And when you think of it that way, it's like canceling multiplication and division at once. It's like timesing 2 and dividing by 2 are opposites. And timesing by 1 and dividing by 1 are opposites. So the whole fraction cancels out piece by piece. Now, that being said, I can do that as long as I do that to both sides. So I'm also going to multiply this guy. Now, I could multiply it by 2 over 1, but I want to make this as simple as I can. And I know that 2 over 1 is exactly the same as 2. So really, what am I doing here? I'm ending up with 2e. 2 divided by 1 is another way to think of it is just 2. And so I have 2e. And that's going to be equivalent to whatever we have left on the right-hand side. Well, we can see after our fractions canceled, we have this, mv squared. Now, keep your goal in mind. Your goal is to get v alone. Now, I have 2 things to get rid of now. I have this m, which is multiplying, and this exponent. If we're working that order of operations backwards, I'm going to need to move anything at multiplying. So let's move the m. It's multiplying, so I'll divide it away. Now, this is where students get tripped up because they misunderstand something. They think they have to try to figure out what 2e divided by m is. You can't figure that out because e is an unknown, m's an unknown. And so literally, when you can't figure it out, you just write it down. You say, okay, that's the same as 2e's divided by m. And that's going to be equivalent to whatever I get after I do my cancellation here. So multiplying by m, whatever number it is, and dividing by m, whatever number it is, that's opposite. So it cancels. And I'm left with v squared. Now, once again, keep your eye on the prize here. You want v to be alone. So what do you need to get rid of? A square. So what's the opposite of square? It's square root. I can do whatever I want as long as I do it to both sides. When you go to college, you'll learn that there's actually 2 answers to this, a positive and a negative, but we don't need that right now. So, and it doesn't come up on the GED. So I'm just going to gloss over that. But the square and square root cancel, leaving me with v. And then you might say, what is the square root of 2e over m? And again, I don't know. I don't have a way to find that because I don't know the letters. And so I just write it. I say v is equal to whatever you would get if you took the square root of all that. So, or let me write it big so you can see it. V is the same as the square root of 2e over m. Done. V is alone. This is solved for v. Guys, I'm super duper proud of you if you stuck with me through the advanced level. But my advanced level students, you guys are the worst at this because you're always like, yeah, it made sense when Kate did it. I'll just skip this. I'm not going to practice. There's nothing like showing up on test day, looking at the problems and going, oh man, you know what I remember? I remember it was easy when Kate did it. And that's all I remember. So guys, go to your practice, you advanced level ninjas. There's practice for you. And by the way, it's designed so that you don't have to do any more units if you can do that practice. So it is the quick route, I swear. All right, you guys, happy learning.